Hello everyone, so in today's video we are going to look at this Aneroid barometer. And before I go into the barometer itself, what does Aneroid mean? Well, Aneroid basically means that you're measuring pressure without the use of a liquid. Now in case of a barometer, that implies that it doesn't use mercury, because a lot of the older barometers were using mercury. So before I dive into what this repair is about, because it's only a slight repair, so let's go over what do we see. Well, first, let's start with the start. We see our bellows. It's basically two like corrugated metal pieces that are welded together or sold together, and here you can see the dimple where they soldered shut. Aneroid barometers are under partial vacuum, the bellows are. So from the bellows we go to this spring, and then from this spring you see a lever here. This goes to this another lever, which here is the part that is missing, so the client transported this barometer and the screw fell out here, which is a calibration screw. Then from this lever we go to this piece, and I don't know if you can, yeah, you can probably see it on camera. So it goes from here and then it ends up in a chain, like a really tiny chain similar to a bike chain. And then that wraps around a spindle. On the spindle there's a little hairspring as well, in order for the needle to return, or the hand to return. So how does all of this work? Well, basically, because of the outside pressure, the thickness of the bellows will vary. That variation gets basically amplified and scaled by mechanical means. So you can see a slight push on here makes the hand move more and calibrate it to a certain degree, which is why that screw is here for. But that screw is now missing, so the barometer is not pointing at the right thing. So let me change camera a bit and I'll put the screw in, and then I'll go about making sure it works again. So now I'm going to put this screw back in, the screw which fell out during transport. So I'm going to be doing this by holding it in front of the hole, more or less, and then just hold the barometer with one outer finger. Place the screws in. And there we go. Now the screw is in. Let me get the dial in place, and then we can kind of calibrate it. So by putting the dial on there, I noticed that the hand is exactly pointing to the pressure it needs to be, because right now we are 1012 hectopascal, which is the same as 760 millimeters Hg, so millimeters of mercury, which is exactly what the dial is pointing at. So yeah, so basically these are millimeters Hg with the 0 removed for ease on the dial, I guess. So yeah, it is exactly right. So now I'm going to observe it over time to see if the barometer actually works or not. And then yeah, if it works, then we'll wrap up this video. See you in a bit. So I was about to put it back in the case for testing, and then I noticed two things. The first thing was I had it upside down, so I turned the hand 180 degrees, so that was not a biggie. And then I noticed this screw here, which basically pokes through the back and is basically also a calibration. So this is basically the calibration once it's in the case, and this basically just turns this whole, like, yeah, basically the whole spring assembly tips it. So if this tips, you're moving this lever, which in turn moves the whole lever system. So this is basically like the calibration once it's in the case. So yeah, that makes it easy, because if it's off once it's in the case, then I can use that to adjust it. And it seems that there's quite some range on it. So now I'm going to go back to get it in the case.